Let's have a look now at some harder examples involving algebra. So we're just going to extend our current understanding and just to sort of apply them to examples that, sort of require maybe a few extra steps than what we're used to. So let's have a look at the first one. Expand a plus b all cubed, hence expand 2x minus 3y all cubed. Okay, so let's start off with the first one. A plus b all cubed. Easy way to sort of think of that is to split up the a plus b all cubed into a plus b multiplied by a plus b all squared. That's an index law, isn't it? Sort of splitting something up into a product so that the indices add together to give you 3. Let's expand the perfect square. Okay, that's going to be a squared plus 2ab plus b squared. And then let's multiply through by a plus b. Okay, so that's going to be a, and sort of a squared plus 2ab plus b squared plus b. That's sort of a squared plus 2ab plus b squared. Okay, and moving on to the next line, we have a cubed plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed. So putting that all together now, okay, and collecting like terms, let's start off with the a cubed. Okay, now 2a squared b, we have another a squared b there, so that's going to be 3a squared b. Now we have an ab squared here, and we have a 2ab squared there, so that's going to be 3ab squared plus b cubed. Then it says, hence expand 2x minus 3y all to the power of 3. Okay, so in this case, our a is going to be 2x, okay, and our b term is going to be negative 3y. So what we're going to do is we're going to substitute these two values, or these two terms in for the terms for a and b in the expression, in just the previously expanded expression. Okay, so moving on. Okay, a cubed, that's going to be 2x cubed, plus 3a squared b, so that's going to be 3a squared multiplied by b, which is negative 3y, plus 3ab squared, so that's 3 times a, which is 2x, times b squared, which is negative 3y all squared, plus b cubed, so that's negative 3y all cubed. Okay, so now let's expand the brackets. So 2x all cubed is 8x cubed. Okay, then we have 2x all squared multiplied by negative 3y multiplied by 3. So let's do the 2x squared first. So that's going to be 4x squared. Okay, and we're going to multiply that by 3. Okay, so that's going to be 12x squared times negative 3y. Okay, so 12x squared times negative 3y is minus 36 x squared y. Okay, hopefully we can agree with that. Okay, next one. So you've got 3 times 2x times negative 3y all squared. So negative 3y all squared is 9y squared, positive 9y squared. Okay, so 9 times 6 is 54. And we have xy squared. And finally, plus negative 3y all cubed. So negative 3 all cubed minus 27. And y to the power of 3 is just y cubed. And there's our expanded expression. All right, let's move on. Next example. So without using a calculator, evaluate 62 multiplied by 58. Okay. And the clue there is we need to use a difference of two squares. We can express the 62 and the 58 in terms of the number 60. In fact, we could write this as 60 plus 2 multiplied by 60 minus 2. Okay? Can you see that even though we're not using algebraic terms with pronumerals, we're using actual numbers, numerals, that doesn't actually change anything. They're still conjugate pairs. This is still a difference of 2 squares. So this is really 60 squared minus 2 squared. Okay, a squared minus b squared. So 60 squared is 3,600 minus 4, and that'll be 3,596. Okay, and if you have to use a calculator to check your answer, 3,596. Okay, right, let's have a look at some other examples. Okay. Always like this one. This is from sort of the old syllabus that where the difference of 2 cubes or 2 cubic numbers was covered. Nevertheless, it's still a useful factorization to know. And this time around, because it's not in the syllabus, I'm going to actually give you the factorization, but then use that to factorize an expression that's kind of similar. It uses the same form. So, given a cubed minus b cubed is equal to a minus b outside of a squared plus ab plus b squared, and if you have a little bit of extra time, you can prove this to yourself. If you multiply this through, you'll end up with a cubed minus b cubed, in fact, which is sort of quite useful. Factorize 64 minus 27 x cubed. Okay. This one is actually a lot easier than it looks. So we could express 64 minus 27 x cubed. The original expression, okay, so this is the definition of the difference of 2 cubes, obviously looks at two terms, or the difference between two terms that are actually cubic numbers. So 64, let's express them as the cube of a number. That's 4 to the power of 3. Okay, I might just put that in brackets. Minus 27x cubed. Now, as the cube of a number, if we take the cube root of that, okay, that's just 3x, all to the power of 3. So, as we go along the way, just make sure that you're doing the right thing. 4 to the power of 3, that's 64. 3x all cubed. 3 to the power of 3 is 27. X to the power of 3 is x cubed. I think we're happy with that. So, the 4 is really our a term. And the 3x is really the b term. Now we're going to substitute these two values into the factorized expression. Okay, so now just going to write the definition out again. I've got the room this time. Okay, so this is going to be equal to now 4 minus 3x outside of a squared, so that's going to be 4 squared, plus ab, so plus 4 multiplied by 3x, plus b squared. Okay, let's expand that. So 4 minus 3x. Now 4 squared is 16. 4 times 3x is 12x. And 3x all squared is 9x squared. So this is the factorized version of the difference of these two cubic numbers, 64 minus 27 x to the power of 3. A couple more. Okay. So factorize x to the power of 4 minus 2x squared plus 1. Now, this is quartic. It's not even quadratic. Or is it? Well, it is quartic because the highest power is a 4. But I guess, could this be reduced down to something that looks quadratic? Maybe. Let's see. In fact, it would be nice if we had an x squared and an x. Would be ideal, or something that resembles that anyway. So why don't we say let u equal x squared, and we're going to masquerade this x to the power of 4 in terms of u, or we're going to sort of express it in terms of another pronumeral. So if we substitute u for x squared, then x to the power of 4 is just u squared. 2x squared, well, if u is equal to x squared, why can't we just substitute the u for x squared? So that's minus 2u plus 1. And that's actually a perfect square, isn't it? That's just the perfect square, u minus 1, all squared. Hopefully, so far we agree with that. We think, okay, well, fair enough, u squared minus 2u plus 1, that is a perfect square. But we don't want the factorized version of this to be in terms of u. We want it in terms of x. Okay, so now somehow we need to eliminate the u, or to substitute out the u and substitute back in the equivalent in terms of x. So that's just x squared minus 1 all squared. Okay, and that really is just, well, that's a difference of 2 squares, isn't it? In fact, I might just use a square bracket here. That's just x minus 1, x plus 1, all squared, isn't it? Okay. In fact, you could express this in different ways. In fact, you could also express it as x minus 1 squared, x plus 1 squared, if you like. Okay, either one's correct, but I think it's quite neat to see it in sort of 2 different forms. Okay, what about the last one? So complete the square on 3x squared plus 5x plus question mark. So we need to find a value for this question mark. Okay, and while you're thinking about that, if you want to pause the video and give this one a go, you may. I'll give you a little bit of a hint. Okay, we need to express this in a particular form. When we're talking about completing the square, we're talking about finding something so that a term, this is going to be the constant term there, so that you can express this 3x plus 5x plus whatever as a perfect square. Okay, and a perfect square has a particular form, doesn't it? So what we want is we want 3x squared plus 5x, let's call that plus, say, c, we don't know what the c is really equal to, okay, so in fact I'm going to introduce you another symbol here. You've seen this before. That sort of means congruent. It actually means equivalent to. Okay, so it's a kind of like an equal sign. It's actually equivalent to ax plus b all squared. That's the form of a perfect square. Okay, at least when we're just involving one pronumeral x, and there's a constant term there. So now if we expand this ax plus b, we can then do something called equating the coefficients, because the x squared term on this side should be equal to the x squared term on this side, or equivalent to the x squared term on the right. The x term on the left hand side should be equivalent to the x term on the right hand side, sorry, and the constant term on the left hand side should be equal to the constant term on the right hand side. So let's do that. Okay, so that's 3x squared plus 5x plus c is equal to, now let's expand this perfect square. That's going to be a squared x squared plus 2abx plus b squared. So what is this really telling us? This is telling us that this x squared term, in fact I should keep the equivalence symbol going there. So this 3x squared here is really equal to a squared x squared. Okay, so a squared is equal to 3, and everything's positive, so we're not going to we don't have to consider the positive or negative case here. Everything is positive, just leave it as a positive number. Okay, so we've got a squared is equal to 3, therefore the a term is in fact equal to square root of 3. Okay. Now if we can find what the b term is and then square it, we've got the c term that we want. Okay, so let's see what happens here. So we have 2ab is equal to 5. So this term here should be equal to 2ab here. Okay, what I've just underlined there in red. Okay, we now have a value for a. Okay, so 2 root 3 times b is equal to 5. Now if we divide both sides by 2 root 3, we have our b term. Okay, So sort of just continuing that along, we have b is equal to 5 over 2 root 3. Now, if we square that, we will have then the term that we want, the question mark, or the plus c that we want. So c is equal to b squared. Okay, so this term and this term are equivalent to each other. They're the two constant terms. Okay, so c is equal to 5 over 2 root 3 all squared. Okay. So we can just square the fraction as is. So 5 squared is 25. Okay, and 2 root 3 squared is equal to 12. So therefore, the question mark will equal 25 on 12. Okay, so writing then the expression as a perfect square. Okay, the perfect square is 3x squared plus 5x plus 25 over 12. And so we've completed the square. And the b term, if we were to put it in brackets, the b term is 5 on 2 root 3.